All right, let's continue from electrodialysis. Okay, first I would like to, first of all, you need to understand, okay, the definitions of electrodialysis. Okay, so electrodialysis is a process, of course, it uses electricity. Okay, so it's a process that uses two things. Okay, two things. One is uses electricity and what? Anything else? And membranes, right? And electricity and membranes. What's the purpose? To remove ions from water. Okay, write this one down. Okay, so I simplify this whole definition to the easy ones. Okay, so what is electrodialysis? Okay, so it's a process that uses electricity and also membrane. Okay, and also membranes to remove ions from water. So it's good for like wet waters. Or seawater. So example like good for wastewater or seawater purification. Okay? Also like for the soil removal. Okay, for the soil removal. Okay, so the best concept was something like this one. So this is the purification of seawater by electrodialysis. So use this for salt removal, right? So Na, the K-ions. Okay, the K-ion will move. The K-ion will move to a cathode. The K-ion Na plus, right? Na plus, right? Will move to the cathode. So in opposite, the anion, negative ion, right? The anion with negative charge will move to the anion. Will move to the anions. Okay, and between the cathode and anion, as I just said, right? Not just electricity, you also need membrane for electrodialysis. So we have two, for example, like this example, we have two membranes. Okay, in between cathode and anion, right? So anions exchange membranes. Okay, so anion transfer membrane. Oh, sometimes we call this anion exchange. Sometimes we call this anion exchange membrane, AEM. Okay, so this anion transfer or anion exchange membrane, what's the purpose for that? This allow negative ion which means the anions to pass through. Okay? So anion exchange membrane, AEM, or anion transfer membranes. Okay? This allows the negative ion to pass through. Okay? On the other hand, the cation exchange or cation transfer membrane, CEM. This allows positive ions to pass through. All right? So everyone okay? Okay. So next, I would like to compare difference between the electrodialysis and reverse electrodialysis. So the main differences are their driving force. The driving force for electrodialysis, ED, is electrical potential. Okay? So, which means it uses electricity. It uses electricity to move the ions to purify the wastewater or seawater. Right? However, so the ED versus the reverse electrodialysis RED, the driving force is the concentration difference. So which means RED uses the difference between salty water and fresh water. But the purpose is not to separate anything. The purpose is they use this to generate energy. Okay? So RED doesn't require energy. They use the difference between the salty water, which means the seawater, and fresh water to generate energy. The generate energies. Okay? So RED uses the difference between the salty, the concentration difference. Sorry, the concentration difference. RED use the concentration differences between salty water and fresh water. The purpose is to generate electricity. Okay, so we have a few more. So those are purpose. Okay, no matter in industry or the city or even animal farming. Okay, and it looks like this. Okay, this is the real dialysis facilities in the industry. Okay. So next, everyone okay? So next, I would like to talk about the biological treatment. Okay, we can also use biological treatment to treat the toxic chemicals, the hazardous waste. Okay, so the biological treatment means we are going to use microorganisms. We are going to use microorganisms to break down pollutant. To break down pollutants. Okay? So the microorganism we can use like bacteria, like fungi, like yeast, like mold, or even some sludge, mobile. Okay? So this table shows the example of pollutants. Okay, this table shows the example of pollutants that microorganism can degrade. Okay? For example, like this one. Acronym trials. Okay? This one can be degraded by mixed culture of yeast. Okay? So we can use yeast, mold, and protozoan bacteria. Okay, the mixed culture of yeast, mold, protozoan bacteria to degrade this. Okay, to degrade this. Okay, and for example, like hydrogenated aliphatic and trichloroaccents, mesochlorides. Okay, these kind of chemicals can be degraded by marine means seeds, okay, by marine bacteria. Okay, all soil bacteria, all sludge bacteria. Okay? And for example, like aromatic compounds such as benzene, phenol, crystals, they can be degraded by something called pseudomonas. Okay, pseudomonas. Okay, pseudo means fake. Okay, by this kind of microorganism called pseudomonas species. Okay, pseudomonas species. So SP stands for species. So any kinds of this pseudomonas species can be used to degrade aromatic compounds. Okay? And the hardest like PCB, okay, like PCB. PCB can be degraded. Okay, PCB can be degraded by pseudomonas species as well. Okay? And in the pesticides, this one is the famous DDT. Okay, the DDT pesticides such as DDT can be degraded by some bacteria or some sludge microorganisms as well. Okay? So this slide tells you different kinds of pollutants. Okay, different kinds of pollutants can be degraded by different kinds of microorganisms. Okay. Okay, next we are going to talk about the landfill for hazardous waste. But this one is very important. For some toxic chemical like dioxin must be burned and destroyed at 850 degrees Celsius. So you cannot just bury it. Okay, you cannot just bury it. Okay, so as I mentioned in the PowerPoint slide, the best for the solid waste, okay, that have just little leaching. Okay, So the solid west, that means the solid west better do not easily leach. Okay, do not easily leach. Okay, I test this in our assignment, right? Leaching. What is leaching? Leaching means the chemical dissolve in the water and move out of the west. Okay? So like organic solvent like dioxin, as I mentioned, it must be burned at 850 degrees Celsius. And some other toxic should be banned. Some toxic chemicals should be banned from landfilling. Okay, you cannot just bury it. Okay, it might contaminate our groundwater or even our surface water. Okay? And also keep this one in mind. For the hazardous waste, must have at least 2 linear systems. Okay? Must have at least 2 linear systems and 2 leachate collection systems for the hazardous waste. Okay? For some household solid waste, you don't need cap. But for hazardous chemical, must be kept. Must be kept. Okay? For hazardous must be kept. Okay? So for hazardous waste, so student put this one is for hazardous. So this is hazardous landfill. Okay, this hazardous landfill. We need at least two or more. Okay, so the reason is be more protective. The reason we need at least 2 linears, okay, because we want it to be more protective. Okay, more protective to stop leakage. To stop leakages. Okay? And also the reason we need at least 2 leachate collection systems. Okay? So we want to collect those toxic liquid, okay, that drain from hazardous waste. Okay, so we should be more cautious. The system, this landfill system should be more protective. Okay. And also we need a monitor well as well. And we need a cap. Okay? And the groundwaters. For the hazardous waste landfill, the groundwater must be monitored. Okay? So this is the requirement, the minimum requirements for the hazardous waste landfill. Okay? 2 or more liners. 2 or more liners. 2 leachate. Okay? A leachate collection above and also between the liner. Okay? And control the run on and run off. Run on and run off control. Okay, for the rainwater and surface water. Okay? At least the water volume resulting from 24-hour and 250 years storm. Okay? And it requires monitoring wells. And don't forget about the cap. Don't forget about the cap. Okay, so this one, student, this one is the hardest. This landfill is not for the household waste. This one is for the hardest waste. The hardest waste. Okay, let's take a 5-minute short break. Okay, now it's 2:15. Let's come back to 2:20.